math learners, Hassan here. Ready for another journey through Algebra One? Today we'll jump into the realm of slope or rate of change. Understanding slope is crucial for interpreting how quantities change in real-world scenarios, such as speed in physics or growth rates in biology. It provides a visual representation of the relationship between two variables, aiding in graphing and interpreting linear functions. Okay, so let's start this topic. Slope basically means how steep a line is. On a graph, if we have a horizontal line, this is where the slope is 0 because there is no steepness. And if we have these two lines, this one is steeper than the other one. Now, how can you find the value of the slope? So here is a quick strategy. For any line, to find the slope, we basically do rise over run. Over here, we mark the endpoints, and we see that as we move from left to the right, we count 1, 2, 3, 4, 5. This portion is called the run, and we count how many units we go up, which is called the rise. So this rise over run is the slope. Over here, the slope is 3 over 5, which is 0.6. Now, another name for this slope is called the gradient. So keep that in mind going forward. Now, in terms of mathematical formula, we can use this formula to find the slope. The slope is change in y over change in x. Basically, this change in y is the rise, and this change in x is the run. So we divide this change in vertical height by the change in horizontal distance to find the slope. For this example, we can see that from these 2 points, the run is 10 and the rise is 8. So 8 over 10, the slope is 0.8. Now let's see how we can use a formula to find the slope. The formula rise over run can be simplified as change in y over change in x. Over here, we can use these 2 points as the 2 coordinates. So let's say this point is x1, comma y1. This is our starting point, and this is the end point, which is x2, comma y2. Now, the change in output or the change in y is this vertical distance, which is y2 minus y1 over the change in horizontal distance, which is x2 minus x1. So once we plug that in, we get the slope formula. So let's see how we can apply over here. We have this coordinate over here, which is 2, 0, and this coordinate over here, 12, 8. So we plug that in over here, 2, 0 for x1 and y1, and 12, 8 is for x2 and y2. So plug that in over here. Y2 is 8 minus y1 is 0, and x2 is 12 minus x1 is 2. So if you simplify, we get 8 over 10, which comes down to 0.8. So you can see that we can also use this formula to find the slope. Now, slope can have 3 scenarios. It can be negative, it can be 0, or it can be positive. As mentioned earlier, if line is a horizontal line, there is no steepness of the line, so the slope is 0. Now, if we need to climb up, the slope is positive, and if we need to climb down, the slope is negative. We can see this in a practice problem over here. From left to the right, the horizontal change is called this run, and the vertical change is called the rise. Now, here is an important note. As you go from left to the right, run is always positive, and rise is always positive, but fall is always negative. Remember, as you are going from left to the right, if you are going up, this is an increment of the y value, so y is positive. But if you are going down, this is a decrement of the y value, so the fall is negative. So for this one, As we are going from left to the right, this is a fall. So this fall over run. Since fall is negative, we divide a negative value by a positive value, so you get a negative slope. Over here, this is the rise. As we are going from left to the right, this rise over run, we have rise as positive over run as positive, so we get a positive value. Let's see how we can find the slope of this line. We can see that we don't have any coordinates, so we need to use the formula rise over run. So we typically mark the endpoints over here, and now we can make a triangle. Now this is the run. We can see that we are counting 1, 2, 3. Since this is run, this is positive 3. Now this is 1, 2, 3, 4, 5. Since this is rise, this is positive 5. So the slope is 5 over 3. That's the slope of this line. Let's look at this last example over here. To find this slope, again mark the endpoints. As we are moving from left to the right, this is the run. 1, 2, 3, 4, 5, 6. We have 6 units. Since run is always positive, we put positive 6. Now we are going down, so this is a fall. So this fall is gonna be negative 2 because fall is always negative. Now the slope is rise over run. In this case, it's fall over run, which is negative 2 over 6, which means the slope is negative 1/3 after simplification. And that's the magic of slope. So when you see a line on a graph, you can definitely find the slope of that line through the strategies that we shared in this video. That's it for this video, and I'll see you in the next one. Now let's get to study.